All right, so to see what features are contained in the DF data frame, we could apply .columns.values. What we retrieve is a list with the data frame's column names. It is important to note that we still have the reason for absence column in there. Then, analogically, implementing the same method to reason columns leads us to an output containing all numbers from 1 to 28, excluding 20. Okay, there are 3 steps to take before finalizing our work on this column. Step 1. If we decide to add all those dummy variables to the current state of DF, we would observe duplicate information. That is, the categorical variable reason for absence on one side would convey the same information as all 27 columns from reason columns on the other. In econometrics, statistics, and data analytics, this phenomenon is called multicollinearity, and it is something that should be avoided in general. Therefore, in our case, we could drop the reason for absence column from the DF table in the usual way. Execute this cell, and done. Step 2. Grouping the variables. If we add all these dummy variables in the DF data frame, we would end up with a dataset containing nearly 40 columns. This sounds like too much when dealing with 700 observations. In a situation where you have so many variables of the same type, and here this regards the dummies, you should always consider the possibility of grouping these variables. By the way, remember that a group can be also called a class. Consequently, the relevant process of reorganizing a certain type of variables into groups in a regression analysis can be called classification. Then, there are various techniques that can help you decide on how to group the variables from your dataset. For our exercise, we will focus on a qualitative analysis because it seems most appropriate. Look at this table with explanations of all possible reasons for absence. You'll see that reasons 1 to 14 are all related to various diseases. This could constitute our first group, or class. The second class, instead, could include reasons from 15 to 17, as they are all somehow related to pregnancy and giving birth. Group 3 would include reasons 18, 19, 20, and 21, as they are all about poisoning or signs not elsewhere categorized. The fourth group represents so-called light reasons for absence, such as a dental appointment, physiotherapy, a medical consultation, and others. Okay, this is how we are going to classify these columns. Therefore, the next thing to do will be to apply this in Python, where we will have to create a new data frame for each group. We'll do this by separating the reason column's data frame. Remember that after splitting this object into smaller pieces, each piece itself will be a data frame object as well. So, let's call these new groups reason type, class number. Then, we must start by applying the loc method to reason columns. Here's how this method works. .loc with a colon before the comma will retrieve all rows available. Then, after the comma, we need to show we are interested in columns 1 to 14 only. Don't forget that loc is label-based, so after the comma, we need to indicate the name of the first and last column of the set of columns we'd like to retrieve. In other words, we would write 1:14 either as integers or as strings. Any of the two will mean we are interested in columns 1, 14, and all the rest that are in between. That's why, after we execute this cell, we obtain a data frame composed of 14 columns. Please feel free to stop and rewatch this part of the video if necessary. And if you find this trick confusing, all we can say is, we are very sorry. But that's how separating a data frame with the loc method is done in Python. So we had better just practice and get used to it. After that, to obtain a piece of DF with columns 15 to 17, we need to constitute the code after the comma with 15:17, because we are interested in the following three columns, 15, 16, and 17. Is this correct? Yes, it is. As an exercise, you could run the same check for the other classes in our table. Class number 3, composed of columns from 18 to 21, and class number 4, made up of the columns from 22 until the last one. Great! To support our reasoning in this lesson, think of the examination we performed a few lectures ago. We created an additional column called check to verify there's only one reason for the absence of a person. Remember? This was a very important confirmation of our analysis because making sure we don't have multiple reasons for absence of a single individual allows us to proceed in the following way. First, go back to Loc 1 to 14. At this stage, you want to substitute an entire row of 14 values with a new single one, in which you would like to obtain 0 if none of the values on the given row were equal to 1. Alternatively, you want to obtain 1 in case somewhere among these 14 columns we have observed the number 1. The former would mean the reason for absence of this particular individual was not from this group of reasons, while the latter would mean it was. There's a method in Python called max that can do a perfect job here. It will act as the second part of our code and will allow us to create the reason type class number columns in the shape we want. To illustrate how this tool works, let's apply it to the first 14 columns of the variable reason columns. Obviously, we must write .max, and then by typing axis equals 1 within parentheses, we will indicate that we are interested in implementing this operation along the horizontal line. Execute, and here we are. We've got exactly what we wanted. Please note that since the maximum value is always a single number, the obtained objects will be pandas series, not data frames. Nevertheless, you can simply think of them as columns, because this structural distinction will be irrelevant when we get to the stage of attaching them to DF. Therefore, to create all 4 columns, we must replicate the same structure to columns 15 to 17, 18 to 21, and 22 to 28. You can also think of the last group as containing all columns from 22 until the last one. Another way to designate this will be to write 22 : at the end. Let's use this syntax here. And now, when we execute this cell, we will actually create the 4 new columns, reason type 1, 2, 3, and 4. Nice! With this, we wrap up what we had to say about the first and second steps from the manipulation of the reason for absence column from our initial data set. In the next video, we'll present step 3. See you there!